So all of the video and audio that you're seeing today will be available on our website probably a week from now. So if you'd like to re-watch the webinar or have some other people go watch the webinar, it will be available for a little while. And yeah, without wasting any more time, I'm going to go ahead and get started. All right, so you'll see here I've got an open profile in my sketch going right now. You can also start with the closed profile. Really, I think there's kind of 3 different techniques to starting any sheet metal piece. First technique is to draw a closed profile. You are then designing from the flat. You're essentially drawing your flat pattern, and you will bend up each flange one at a time. I find this to be the most difficult. You know, we would like to design our 3D shape and let SolidWorks come up with the flat pattern for us. So what I'm actually going to do is start with an open profile. The third technique is converting to sheet metal, and I'll show you that a little later. So you'll see here I've got my sketch already dimensioned. I'm ready to go to my base flange. Because it's an open profile, it knows right away to add thickness to my lines, add bends at my corners, and it's giving me my sheet metal thickness right away. So come over to the left, we fill it out a lot like any Extrude property manager. So let me go ahead and pick some sizes here. Okay, next, I can assign my sheet metal thickness and my bend radius right away. I don't think this is the best idea. A lot of your designers might not know the thickness values for your different sheet metal gauges. They might not know your bend capabilities given your gauge and material. So I find it's a much better idea to use gauge tables. Right, SolidWorks has given you a handful of sample gauge tables already. So I would certainly copy these, you know, go browse to where they're located. You'll be able to find where they're located up in the system options, file locations, sheet metal gauge tables. You can find the folder that these are in, copy them, paste them, make them your own. Okay, so I'm going to come in here and grab my steel gauge table. Okay, if I browse to that, you know, that's another way I could locate where that folder is at. Okay, now I'm pulling from a list. You'll see once I choose my gauge size, it goes ahead and grabs the thickness value, and it only gives me certain bend options that I'm allowed. Okay, of course, I can override these values on the fly if I would like to. By default, it is adding material inward, so you're essentially drawing the outer bounding box. If you want, though, you could add material either direction. Okay, and lastly, building in bend allowance, K-factors, bend deductions. Okay, you can enter that default value at this moment. Later, I can go bend by bend and choose different options. Okay, or this is kind of new. This is new to 2011. You can load in a bend calculation table. It's an Excel file. I'll see if I can't find a table that I have of this. But essentially, you're going to lay out, you know, given a certain range of angles, you know, what you want to do for your calculations. There's also a sample table of this located somewhere. You could copy that, edit it, and make it your own as well. Okay, if you don't know what those values should be, using a K-factor of 0.5 is a good safe bet. And lastly, in the event that you need relief cuts, pick your default relief type. Again, I can go corner to corner and override this default choice later. All right, once you hit OK, we're certainly able to flatten that out right away. Take a look at our flat pattern. If I want to go change any of those choices I just made, I can edit that feature. Okay, pick a new gauge size, etc. And now any flange I make, if I hit the plus sign, I'm going to find where my sketch is located. and those individual bends. Here's where you could go edit a single bend, pick a new radius value for that specific bend, a new bend allowance, and again, what bend order that is created in. All right, so again, I'm going to try to hit pretty much all the functionality. As you've noticed, a lot of what I've done so far is very basic. We'll start to get more and more advanced as the webinar goes on. All right, but now that I've got my first shape, I'm going to come create an edge flange. Okay, to do an edge flange, I can just pick any edge on the model. Okay, and I can start pulling it off in either direction. Okay, with the preview right now, I don't worry about exactly how long I make it, just which direction I'm going in, and I click for OK. And then I'll use the left to fill out anything I need. Okay, like maybe I would like to change my angle here. Get a new angle for that bend. Next, if I am measuring this flange, where am I measuring to and from? We have a new choice here in 2012 that makes the most sense. It measures to the tangency of the bend. Okay, in your manufacturing, that's where everyone's going to be able to actually create that measurement. So it makes the most sense to me. So that's a nice new option. Maybe we'll come in here and pick 3 inches. Next, where does that bend sit relative to the existing edge? Okay, got a lot of choices here. And another new one to 2012 is, again, tangency to the bend. Okay, I'm going to go with that option here. Okay, there's a lot of other information available, or a lot of other things you can fill out here. Okay, this is kind of an interesting one. If I would like this new flat face to be coincident with some other flat face, I can select that. It will override my angle choice to make sure I have nice flush components. I'm going to go ahead and hit OK, and you'll see it throws that in there. The next, we create another edge flange. There's another piece of functionality in there I did not look at. Okay, also, when I go to pull this up, I can choose to snap to a corner right away. Okay, I want it to go all the way to this top corner. Okay, by picking that, I've got it up to vertex option chosen right away. Okay, next, I'm going to come down and choose my flange location. And the way I have it right now, I'm going to need some auto relief. I don't really want that. So I'm going to choose to start my bend, at the edge. And lastly, the main piece of functionality here, you can edit this flange profile right away. I see a lot of people hit OK and then go cut this flange to shape. Okay, that is not necessary. You can edit your sketch immediately. Okay, I'm going to hit normal too. Okay, we can even come in here and copy some of these edges. Okay, with the convert entities. And then I'm going to come in here and finish this off. Come trim away those excess lines. And maybe I would like to throw in some fillet radiuses here. Okay, as soon as you're done editing your sketch, you'll just go ahead and hit finish. And now I've got that flange in here. All right, in the past, mirroring sheet metal features was kind of difficult. It was hit or miss. Lately, the last 2 versions, I would say, a lot of the sheet metal features mirror real nicely. We could certainly mirror this edge flange to the other side, so I don't have to recreate that work. Okay, next, I'm going to come in here and make some cuts on the back side of this face. Okay, I'm just going to do a simple rectangular shape. I'm not even going to dimension it just for time's sake. So I'm going to show you 2 different techniques for cutting into this model. Okay, I can certainly cut it from the bent position or folded position. Okay, I'll just choose the depth I would like. I'm going to talk about these features here a little later, but you will certainly want to pay attention to these. These are special sheet metal options. Normal cut, length to thickness, cuts to my gauge thickness, things like that. So definitely want to pay attention to that as you're working. And again, I'm going to touch on that a little bit later. Okay, and you'll see it makes a really nice cut when I take a look at my flat pattern. Okay, the cut is in there as well. There's another choice. Yeah, I see a lot of people do this. They'll flatten the model and then create their cut. Okay, this is not the best option because it's going to put my cut under the flat pattern. And due to parent-child relationships, when I go and suppress this flat pattern, it is going to suppress my cut, and I'm not going to see it in the model. Okay, I'm going to go ahead and do that just so you can see the effect. Okay, we'll go ahead and do a through all cut. Again, it has to put it under the tree due to parent-child relationships. As soon as I unsuppress my flat pattern, my cut is now missing. There's no other way around that if you make your cut that way. Here is the intended technique to create a cut if you would like to cut the flat pattern. You use your fold and unfold features here. So first go ahead and unfold the model. Okay, we want to leave this face fixed, and I'm going to unfold this bin. Notice all the other bins are maintained. Okay, so instead of unsuppressing the flat pattern and putting my cut below it, it gives us a new unfold feature above the flat pattern. So now my new cut can go right in between the two. So I'm going to come in here and make yet a third cut. And we'll go ahead and put it on this other side. And so again, I'm using my normal extrude cut tool. Actually, here's a good instance where you might use the length to thickness, right? Cut just the gauge of my sheet metal, nothing else. Okay, so it's kind of like an alternative through all cut or an up to next type cut. And now to get it back to my folded shape, I run the fold command, tell it to collect all bins, so I don't have to go select those bins. Hit OK. That is the intended way to get that type of cut in the model. Okay, I'm actually going to suppress these cuts. Okay, I know this isn't the best place to do this, but there is a cross break tool. I'm just going to throw it in right here. Keep in mind, this is just a dumb sketch. Okay, it did not actually bend or change any of the geometry of my model. But the key there is these lines will show up on my flat pattern. They will show up on my drawing. Think of it more as an annotation. Okay, so that's kind of a nice new tool. Next, maybe we'll take a look at our hem. It works a lot like the edge flange. You just select your edge, come in and choose all the dimension values you want for your hem shape. Okay, most of the options in those property managers are self-explanatory, so I'm not hitting everything. All right, let's see. What else do I want to do here? All right, I'm going to kind of back up just a little ways. In fact, I'm going to get rid of most all of this. There's one other thing that I would kind of like to show in this example. All right, so there's another nice little feature here to help close up boxes. Okay, I'm going to do another edge flange again. We'll pull this edge up. I want it to go to the height of that corner. We'll select that corner and hit OK. Okay, now I really like to close this up. Okay, your corners tool here has several different corner features. Okay, we'll take a look at all of them. First one is close corner. Okay, rather than editing a sketch or doing some kind of tab onto this to close it up, your close corner feature, you just select this in face. It finds the neighboring flange and extrudes up to it. You've got your choice. You could kind of miter that or do kind of more of a butt technique. Okay, so both of those, you can take a look at the profile. This one's extending both options. That one's giving me a sharp corner, doesn't look so good. But right here's a great option, but maybe we want to weld this, so this might be a better option. You'll see it's actually trimming this back, and I could actually set, okay, sort of a gap for welding. You probably go with that tighter gap. It's a really nice tool there to help add some extra intelligence there to your sheet metal design. Okay, nice thing is if I go and edit this, okay, and change my angle, everything updates. Notice my edge flange got shorter, my closed corner got longer. Okay, if I go to my flat pattern, there's another corner option. You'll see it shows kind of a funky little relief cut here. Okay, there is a corner trim feature. Okay, you'll come and select that edge. You can choose from some kind of standard cut shapes. Okay, something that makes sense, or you can draw in your own corner shape here as well for your relief cut. Okay, one thing is that corner treatment, again, parent-child, it comes after the flat pattern. You will not see it correct in your folded state, but when you do your flat pattern for your drawing, you are going to see that, that special relief cut there. All right, that's going to be it for this example. Now I'm going to cruise through some shorter, smaller examples. Okay, first let's go ahead and hit our third and final kind of technique to start a sheet metal piece, converting to sheet metal. Okay, so here you'll see I chose to draw my shape as a solid. Okay, maybe I drew a solid because it was a lot easier to get this geometry knocked out as just a basic solid extrude. Or maybe we used to make, this is probably the more likely example, we used to make this part from a solid block of metal. We would just machine it out. But it's costly, it's heavy, it uses a lot of material. So I'm going to go for a cheaper, lighter design with a couple welded sheet metal pieces. Okay, a few years ago, I would have to rip my edges and insert my own bins. It was really tricky. It was like a 3-stage process, and it would only work maybe 25% of the time. 2 years ago, they added this new version of converting to sheet metal. So I no longer use these two features at all. I only use this one, and it tends to work 95% of the time. It's very robust feature, and it's a one-step process. So here's how it works. Okay, I pick where I would like my flat face to be. It'll unfold the rest of the bins from there. Then I just start left-clicking the edges that represent the bins. Okay, every other edge is either going to be a rip or an empty face. You'll see if I hit OK right here, it forms my two bins, eliminates the other faces. This is the first sheet metal body I would like in this model. There'll be a couple other bodies, but notice I lost my solid body. And I only have the sheet metal body now. The trick here is, if it is going to be a multi-body sheet metal part, Okay, roll back up. We'll grab our body. And then I'm going to run my move copy bodies commands. Okay, you can find this under insert features in case it's not on your toolbar. Don't translate it anywhere, just make copies. And I know I'm going to need 4 copies of this body. So I'm going to hit OK. Okay, you'll see I've got a bunch of copies now. So when I roll back down, I still have these other copies available. I'm going to hide all but one of them. I'm also going to hide my other sheet metal body for now. And then I'm going to run my convert to sheet metal tool over and over again. So this time I'm just going to choose the side face and OK. We'll hide that and show the next body. Okay, I'm going to hit the other side face. We'll hide that and show our next copy. And then I'm going to run my last sheet metal command. Okay, I actually created one too many bodies, but that's okay. In fact, there's no harm in leaving that there. All right, now you can see I've got some edits to make. Okay, I've got some overlapping I did not intend. Okay, so if I go to my second conversion, I could then reverse my thickness direction. Okay, and you'll see that little issue is corrected. I'm going to need to do that a second time. Okay, and now I've got a nice little sheet metal box kind of ready to go. Okay, another kind of cool little piece here. These are 2 different bodies at the moment. I'm going to grab my edge flange, and I'm going to start pulling off this edge. If I go and snap it over to this edge, it will actually glue these 2 bodies into one. You'll see now if I highlight this body and then hit flat, okay, it created those into one sheet metal piece, maybe a little quicker to manufacture and a little less welding. So that's kind of a cool new feature. Now that we do have a multi-body sheet metal piece, I'm going to go ahead and right-click this and delete this body out of here. Okay, I can find my 3 sheet metal bodies. It is now kind of like a weldment cut list. I need to right-click and update this before I start my drawing. Notice it can find similar sheet metal bodies, and it will put them in as a cut list item. I'll get a quantity of 2 on a bill of materials on my drawing, things like that. But when you do your flat patterns, notice it's grayed out. Okay, I can't click it. You have to highlight one of your bodies first, and you can flatten one body at a time. I can flatten this body, get out of there, then flatten this body. Okay, so you got to look at them one at a time. One option though you have is you can right click. You have some special sheet metal options. If I do toggle flat display, I can look at the flat pattern while in the folded state. That can sometimes be helpful. And there's one last option in here, export to DXF. Okay, I can now send this file to a DXF, send that to my laser cutter right away. Okay, let it know it's sheet metal. That way it unfolds it. You know, maybe I want to send the bin lines, and that's about it. And if I hit OK, take a couple seconds generating that DXF. So now I can totally skip the drawing stage if I just want to get this thing cut right now. Send it to my, my plotter or my cutter, whatever I've got. Okay, I can even get rid of excess lines if I want to. Maybe these are going to be machined later or something like that. I can start removing these entities. All right, so that's it for my convert to sheet metal piece. Okay, for those of you that have seen our What's New webinars this year, you've already seen this example, but for everybody else, this would be good to see. Okay, I'm going to use these forming tools right out of my forming tools library. Now, I do have an example I'm going to show here in a second on how I created these forming tools. But until then, I'm just going to go ahead and start using them. Okay, so here maybe we want some wire tie clips. I can drag and drop this onto my face. New to 2012, I can now rotate my tool, flip it in the punch inside, outside. And then I've got a little position tool. So this will allow me to quickly snap on more instances. In the past, I would have to create a linear pattern or a mirror feature to do that. Okay, but now I can quickly drop in 4 at once. Notice I did away with my location sketch I used to use because I have the flip option and the snapping option. So I can get those forming tools located a whole lot quicker than I used to. Another new piece of functionality here is it also supports configurations. So in the past, you would have to have a lot of subfolders for your forming tools, a lot of forming tool files, but you'll see now I only have one louver file with all my configurations in it. So it makes that a whole lot easier. And again, if we go to our positions tab, I can quickly drop in a lot of these. Okay, looking at my preview right away, I can see I chose too large of a configuration. We'll do a slightly shorter one. All right, so getting those onto my body a lot quicker. Now let's take a look at our drawing. Okay, I can drag in all my standard views, but of course what we're most interested in here is our flat pattern. Okay, I'm going to go ahead and drag and drop this onto my sheet. Okay, at first this looks exactly the same as it always has. You just drag that flat pattern on. You know, maybe I move my flat pattern down into the corner here and I do throw in some views. You know, we'll do our front view and maybe a top view. Something like that. There are some new enhancements here, though, to 2012. Okay, if I go throw in some tables, we now can do a bin table. I like this a lot. Now, this is a real simple flat pattern. There's only 4 bin lines, only 4 bin notes. But that can get really messy really quick. And you'll see, even with the simplicity of this design, my text is overlapping edges. It just doesn't look very clean. It's kind of hard to read. Okay, in 2012, I can now throw in a bin table into here. Okay, it eliminates a lot of those notes and instead throws in tags for me. Okay, now I can refer to the table to get my bin angles, radiuses, things like that. Okay, another piece of new functionality is another table here. Okay, and that's my punch table. Okay, I'm going to come pick a 0, 0 location to measure from, and we'll hit OK. I totally forgot a step. Let me try that again. In addition to picking your 0 coordinate, you also need to pick the flat face where your punches were located. And now I'm going to get a nice little punch table. We can use our bottom right corner here, shrink that down, and then snap this into the corner. Okay, so my punch IDs could, refer to my punch tools. I got XY locations, orientations, quantities, and you'll see a bunch of tags. Just like a whole table, I can right-click this here and combine same tags. Expand my tags, or combine same types. Okay, again, kind of clean that table up, and again, now it tags my drawing, keeps it nice and clean. So a couple new pieces of functionality there. All right, notice here I've got kind of a warning. My flanges are overlapping. Same thing would happen if I flatten this and I have some overlapping entities. I would get a warning. So here I'm just kind of doing a good example of a jog. Okay, you got to start with the sketch. I'm going to highlight this line and convert entities in case I decide to change some dimensions later. Okay, and now I'm going to use my jog tool. We'll leave this face fixed. Okay, and you'll see it starts my jog. Okay, with a couple good selections for bend location, okay, I will be able to place this jog, in a way where it comes up and over that other flange. Okay, I want to control how I measure it, my angle, things like that. And of course, bend radiuses. Okay, notice how I kind of lost my preview at one moment. Okay, that's a good indication that my jog is going to fail. It definitely has something to do with my radius choices, jog heights, angles, locations. All those kind of combinations can cause, my jog not to fit, so you can see it failing. All right, so no bother even hitting OK until I fix those values, those choices. All right, next here I'm going to show you how I created that louver forming tool we saw in the last example. Okay, here I've kind of created a block. Here I've got a profile for my sketch. Okay, I'm going to do a short revolve here. We'll go just 180 degrees, get some nice overlap into the model. And we'll throw in our fillet. This fillet choice is pretty important. This fillet value needs to be larger, larger than my gauge thickness, or my forming tool is going to fail. It won't be able to put that radius in the sheet metal. So you need to kind of pay attention to the radius choices that you choose here. All right, here's a good example of where I might want to have some different options, keep edge, keep face, things like that. We'll go ahead and throw in a radius. Ugh, that's not at all what I wanted. Let's see here. I need to make this a little bit taller, I think. Yikes. All right, let me go ahead and adjust my fillet once I get that fixed. There we go. That looks a lot nicer. And now we can run our forming tools command. All right, you do not need to make the forming tool look exactly like the real tool. The important piece is the shape on the top of your block. Now this block piece is not totally necessary, but I like having it. It makes it a little more intuitive. All that's important is everything above this blue face, and everything below that blue face does not tend to matter with my forming tool. All right, so if I have my forming tools command here, this is not for dropping on forming tools. This is for creating a forming tool to put in your library. My stopping face, okay, it's going to kind of take this tool and push it up to the sheet metal until the stopping face collides with the sheet metal body. Okay, that's how far it's going to go. Faces to remove. Okay, this you do not need. You could leave this blank, but then I'm not going to actually see the proper cut to the sheet metal. So if I select this face to be removed, that face is going to be open and become a hole in my sheet metal. These faces left gray will be where I see the bends and folds in my sheet metal, the deformations in the sheet metal. Okay, it kind of color codes the model here. This forming tool is ready to be put into my library. Okay, I can now browse to my forming tool folder. Okay, I like to select my folder and then hit Add to Library. Okay, I would choose my forming tool body out of the tree. Give it a nice description. Okay, things like that, so people know how to use it. Give it a nice name with size and information like that. One last really important piece to this is to right-click your folder and make sure it's designated as a forming tools folder, or it will not work correctly. You already have a forming tools folder in your design library, just kind of filled with sample forming tools. So I encourage you to take a look at those. All right, lofted sheet metal. Okay, lofted sheet metal is possible, but it's a little bit tricky. Okay, there's a couple very special requirements for it to work. I'm going to cover what those are. So a lot of people actually call in the tech support about their lofted sheet metal bodies not working. Okay, it's every single time it's because you're not following the rules. And again, it's just because most people don't know the rules. So I'm going to go ahead and cover those rules right now. Okay, rule number one is you do need to put in your bend radiuses. So you'll see I am missing my radiuses here. I'm going to go ahead and put those in right now. Okay, I'm going to go for maybe 1/2 inch radiuses. All right, rule number two, it cannot be a closed profile. Your profiles for your lock cannot be closed. Let me reword that. So you'll see here, this is kind of the technique I've found to work pretty nice. Okay, I'm not totally sure I want these at an angle. Maybe all three of these lines are vertical, maybe not. It doesn't matter too much, but what I need to do is trim out some sort of gap. Excuse me. So make this gap the actual value of the gap you're going to see in real life when you fold this sheet metal body around. You can make this gap as tight as you would like, but you have to have some kind of gap. So that's rule number two. And rule number three, and the last sort of rule, has to do with the next set of lofts. So this loft, or this profile right here, has to have the same quantity of entities around the profile. So if I count around my rectangle shape, I've got 1, 2, 3, 4, 5, 6, 7, 8, 9 entities. This circle also needs to have 9 entities. So that's kind of my final rule. And of course, it also has to have the break. So before I forget, I'm going to highlight these 3 lines, convert these entities. We'll make them construction. And then we'll trim out our circle. Okay, next I need to use my split entities tool. Okay, you could right click and then your circle and do split entities. That way I have 9 segments. When I'm done, those segments are going to have the same radiuses. They're going to be concentric or co-radial. So it's not going to really affect my shape, but I have to have that many entities in here. Okay, this is kind of an interesting technique to align my entities. If I start drawing these radial lines out to all the corners, of my first profile, it can help locate my split entities. Okay, but you want to do something to help control, what these bent faces are going to do as they loft up. So now you can see where this space down below at the bottom of my profile is going to loft up to this face. But same thing here, I need to highlight these lines, make them construction, and now I run my split entities commands. Okay, I'm going to drop all my entities down. Hit OK, and now I'm going to come in and add coincident relations. Okay, however you decide to place these split entities, just be sure that you fully define them. That way, if you ever need to change their locations, you can either do it with relationships, so your models update intelligently, or you can do it, do it numerically with angle dimensions, something of that effect. Okay, you'll see here if I decide to change the shape of my circle after the fact, those entities update real nice. Okay, so it definitely takes some extra work, but I'm now set up to do my lofted sheet metal bend. Okay, you'll see I'm getting my preview. It looks nice. I can go ahead and hit OK. Okay, if I go ahead and flatten that out, I definitely get my nice shape there. Okay, if I if I right-click my free-form bend under my sheet metal shape, go to Edit Feature, I can come back and control, the thickness, things like that. All right. Okay, next, just a few more examples. Okay, here I'm going to explain the options we saw in our cut commands. Okay, first I'm going to go ahead and take this circle shape. We'll do an extruded cut. Okay, I'm going to use my select contours to just cut my circle. And I'm just going to kind of free drag this cut through the model. Okay, I'm going to forget to use my sheet metal option here, normal cut. Okay, without that, when I take a look at this cut, notice the edges look nice and clean here. Okay, that's kind of what we're typically used to seeing when we do cut. But I've got an issue when I do my flat pattern. You'll see that now whatever tool I'm going to use to cut this cannot come in at a normal angle of 90 degrees to my sheet metal body. So a laser cutter, most cutters out there are not going to be able to make this shape. So this is kind of not a preferred option. Okay, I'm going to go ahead and reuse my sketch, make another cut. Again, this time I'm going to cut just my slot contour. So pay attention to this option when you're using sheet metal. It's on by default, so you should be safe. Now here, when I look at this cut, the faces are not normal, but when I flatten my body, okay, now they are normal. So SolidWorks does a little math to make sure that this cut is made from the flat, normal from the flat, and then when you go ahead and bend it, you might get some odd exposed faces, but that's what's going to happen in real life anyway. So it's going to get you a much more accurate manufacturable model. All right, here's the last piece of what's new in 2012 with sheet metal. Okay, it's sheet metal costing. Okay, so this is only available in SolidWorks Professional, I found out. So if you only have a standard, you're not going to be able to use this new tool, but everyone else will be able to take advantage. You have some sample default templates already set up. What you're going to want to do is use that sample template, launch the template editor. Okay, you can now step through this template. Notice I can do setup costs, or any new tools required. What do I have to do with machines? All your material choices, thickness choices for those materials, and then prices for every material and thickness combination. Okay, then all your cuts. Okay, and again, your cuts are specific to material and thickness and cutting operation. Your bend costs, library features, again, like punches, things like that. And then any other custom tasks like painting and things like that. So, maybe you manufacture your own sheet metal parts and you, again, want to make them cheaper, or maybe you want to get quotes for other customers out the door a little quicker. Or what you can do is get your vendors on the phone, walk through this template with them, or maybe have them create the template. They can send it to you, and now you could kind of do your own cost estimations in the future before ever even sending files over to your vendors. So that'll be huge. I also see it being a huge benefit with design reviews, because it will generate reports for you showing the cost breakdown. You can set a baseline, and as you make changes to your features and how you create them, it'll give you a cost comparison so you can show how you've been looking at how to make your sheet metal pieces cheaper during design reviews. Lastly, you can come in here and take a look at the cost breakdown. Find your most expensive cut paths, most expensive bins, library features, and maybe find where you can kind of shave some costs off this part. So SolidWorks actually flattens the model, starts measuring edges and surface area and things like that to create that cost breakdown for you. So nice new piece of functionality there. All right, just two last little examples here. Okay, here I'm going to kind of delete my miter flange, recreate it for you. Okay, I wanted to do this as a separate example just to show you that you can create really complex flanges with one feature using the miter flange. What I see a lot is that people will create one edge flange, and they'll do that for all four edges around the model. And then they'll create another edge flange, do that for all four edges around the model, and then another edge flange, and then another edge flange, and then close the corners. But you'll see here I've got a fairly complex shape. The key here is your sketch needs to be on this face. Okay, it is going to if you sketch on this face, it will travel down this edge first in orange. It's going to go in that direction, and then I can propagate it all the way around my shape for my miter flange. Okay, another requirement is that you have enough length on all your edges to fit your bend radiuses. So as long as you follow those rules, all you got to do is take your sketch. We'll do a minor flange. Okay, I can hit OK at this point. Maybe it's not really a minor flange. Maybe it's just a complex edge flange. And this is all I want. I can hit OK. So again, complex edge flanges, you might trick it and use the miter flange tool to do those. You can save yourself a lot of work. But of course, if you are carrying these flanges around all your other edges, you'll definitely want to use the miter flange. And you'll see here I can go ahead and build in my weld gaps, start and end offsets if I don't want the flange to go all the way to the end of the model, things like that. You hit OK and you'll see I have a nice little edge here for welding. I can weld this seam up and make a nice wider tight box here for my model. Okay, it's even got the little trap around the edges for welding. All right, last example here. So I lied earlier on accident. This is the last piece of what's new functionality in 2012. And that's the swept flange. Okay, it works just like any other sweep that you might have done. You need to draw some kind of profile, only it needs to be an open profile, right? You can put a really small gap in there, but there has to be some gap, and then a path. Okay, so all we have to do is select our profile, select our path, and then again, choose our gauge, bend allowance, bend radius options. Okay, so you can create really complex sheet metal shapes. Definitely going to be great for those wire channels and other types of features that you might be making like this. And of course, we can flatten it. Okay, it'll throw in all of our bend notes and things like that. All right, so that's going to conclude my sheet metal webinar. Thanks again for joining in. I hope you guys enjoyed it. Again, I'm going to put the recording on our website. It does take a little while to get up there. If you would like to see it a little quicker, let your sales rep know, and we could send you a link to where the webinar is auto-saved. But if you have any questions, feel free to email support or info or myself. And yeah, we'll see you next time at the next webinar. Thanks again, and take care.